Children, I'll continue. See here, this is the YouTube containing agar-agar gel mixed with one of the inert electrolyte like potassium chloride, sodium sulfate, etc. Here, the ions, the solution present in the two beakers, solution which is present in the beaker cannot get poured out, but ions can move through this salt bridge. Now, when the switch closes the circuit, electrons flow from zinc strip to copper strip. This is the first case. When the switch is closed, electrons flow from, that is from anode to cathode, that is from zinc rod to copper rod. So, what is the reaction taking place in the anodic compartment? Anodic compartment. In the anodic compartment, oxidation takes place. So, here zinc is oxidized to Zn2 plus by losing its electrons. The Zn2 plus ions enters the solution and the electrons enters the zinc metal, then flow through the external wire and then enter the copper strip. So it is having a negative charge, that is zinc rod giving Zn2 plus 2 electrons. Here loss of electrons happens, so it is called oxidation. Oxidation means loss of electron. Now, what reaction taking place in the cathode? Cathodic compartment. In the cathodic compartment, electrons flow through the circuit from zinc to copper, where the copper 2 plus ions in the solution accept the 2 electrons and reduce to 2 copper, and it is deposited on the electrode. So here it becomes positive, that is Cu2 plus gaining the 2 electrons and forming copper metal which is deposited on the electrode. Here gain of electron takes place, so it is called as reduction reaction. It is called as a reduction reaction. Anodic compartment oxidation reaction, cathodic compartment reduction reactions. Now, salt bridge. The electrolyte present in two half cells are connected through the salt bridge. So, we know in the anode oxidation takes place, in the cathode reduction takes place. So, in the anodic, due to the anodic oxidation of zinc electrode, result in the increase in concentration of Zn2 plus. Zn2 plus concentration increases and the solution contains more Zn2 plus than SO4 2 minus ions. It consists of more Zn2 plus ions than SO4 2 minus ions. And the solution in the anionic compartment becomes positively charged. Anodic compartment present become positively charged. Similarly, the solution in the cathodic compartment would become negatively charged as Cu2 plus ion reduced to 2 copper. Here also it contains more number of SO4 2 minus ions. Here it consists of Zn2 plus ions more. Here it consists of SO4 2 minus ions. To maintain the electrical neutrality in both the components, both the compartments, the non-reactive electrolyte, it is KCl, move from the salt bridge and enter into the anodic compartment. It moves from here to here. At the same time, for example, KCl minus, if it is moving from here to here, K plus ions move from here to here. So here ions flow. With the non-electrolyte, here if we are taking KCl, Cl minus ions move from here to here, K plus ions move from here to here. At the same time, electron flowing through here. So, electron flow from negatively charged zinc anode to positively charged copper cathode through the external wire. At the same time, anion, anion, K plus anion move towards the anode and cations move towards the cathode compartment. This completes the circuit. This is the galvanic cell. Now, how will you write the galvanic cell diagram? How will you write? See, cell diagram, zinc rod, zinc sulfate solution containing the zinc ions, copper rod, copper sulfate solution. This is the single line represents phase boundary, single vertical bar, double line represents the salt bridge. This is the salt bridge. It will not allow the solution to mix, but it permits the ions to flow from here to here or from here to here. But the solution will not get mixed. So, the anode half cell written on the left, cathode half cell written on the right side. The anode and cathode extreme left and right. Then the solution kept inside. EMF of the cell is written at the last. E0 is equal to 1.1 volt on the right side after the cell diagram. This is the galvanic cell notation. This is the anode compartment, extreme. This is the cathode compartment. In the anode compartment, anode extreme left, cathode extreme right. Standard EMF E0 1.1 volt. This is salt bridge. This is phase boundary, anode half cell, cathode half cell. This is the galvanic cell notation. This is very important 3-mark question. Daniel cell also important, is given in book page number 45 and 46.